Welcome to Arduino Level 2, Controlling Motors and Servos. This is the second workshop in our Arduino Educational Workshop series as presented by the Integrated Teaching and Learning Program at CU Boulder. My name is Lauren, and I'm here to guide you through a number of exercises that make up our self-paced Arduino Motion workshop. To complete these exercises, I recommend that you have an Arduino kit and access to the Arduino software. Alternatively, you can choose to complete this material using Tinkercad's circuit simulation software. If you missed the first Arduino workshop, navigate to the ITL program's Skill Building Workshops page. There you will find the Canvas course listed for Arduino Level 1, Intro to Inputs and Outputs. In this workshop, we will learn how to control motors and servos using an Arduino UNO. This workshop will consist of a mix of slides, hardware, and software to help you master the material. Let's get started with a quick review from our previous Arduino workshop material. Do you recall how to blink an LED using an Arduino? If you do, pause the video right here and get your hardware and software set up. If not, keep moving and I'll go through the exercise to remind us how this is done. For this next part, we're going to be using the physical hardware to build the circuit. Our task is to blink this red LED. To protect the LED from overcurrent provided by the Arduino, we need to include a resistor. You can determine the value of the resistor by looking at its color bands. In our case, orange, orange, brown translates to 330 ohms. Finally, in order to hook up the components back to the Arduino, we need some male-to-male jumper wires. So let's spend a couple moments refreshing on how the breadboard works. Remember, it's just a bunch of plastic and metal pins, nothing special. Its job is to help you better organize your circuits, both safely and efficiently. The outside columns are considered power rails that run top to bottom. The rows in the middle of the boards run left to right, but are separated in the very center. Let's set up our circuit. First, our resistor needs to be placed into the breadboard by selecting any two separate rows and sliding the leads of the resistor firmly into the breadboard contacts. Next, we need to place our LED. Keep in mind they have polarity. Energy only safely flows one direction. Referencing our schematic, we know the short lead or negative side of the LED should connect to one side of our resistor. Finally, we need to connect our circuit back to our Arduino. We'll use a colored jumper cable to come back to the Arduino on the positive side of the LED, and a black jumper cable to go back to the Arduino on the negative side of the resistor. Bringing our Arduino back into the picture, we're going to connect the jumper on the LED to row 13 on our Arduino. Finally, to complete our circuit, the black jumper on the negative end of the resistor to ground. From here, we should be able to upload our code and see a successfully blinking circuit. So let's jump back to the code and see just how that's done. So on the left-hand side, we see within void setup and void loop, the code necessary to blink an LED on pin 13. Don't forget your pin modes. That's what sets up the hardware to make sure it can give out the power that you need to blink the LED. Within the loop, you see high and low, which actually signifies when the LED will be on and off, separated by delays. Remember, that's delay in milliseconds, so it's going to delay by 2 seconds and then delay by 1/10 of a second. On the right-hand side, you see how the LED is hooked up to pin 13 using that purple wire. Then, it goes through the LED to the resistor using the green connecting wire, and then it finishes the circuit from the resistor back to ground using the black wire. Together, all of this will make your LED blink on pin 13 and is a good refresher of all the things that we learned in our previous Arduino Introductory workshop. Now that we've refreshed on our code, let's see how we did hooking it up. If it blinks, great job. If not, check the onboard LED labeled L next to pin 13 on your Arduino. If that's blinking, nice, your code is correct, and you should double check the hookups on your breadboard. If that indicator light is not blinking, double check your code and see if that's the problem. Once you've got both working, let's move on to our first Arduino Motion topic. So what about this content? Well, today we're going to talk about how to build a Wally, or in this case, what kind of hardware you need in order to be able to build the Wally. On the bottom side, where his little wheels go, all he needs to do is be able to move forward and backward. These are just brushed motors, and they can change speed. They can change how quickly or how slowly that little wheel rotates on the top. On the right-hand side, he has little arms and hands and those eyes that move so characteristically. These are a different kind of actuator. They're called a servo, and they change position. We're going to be using both of these today in our workshop. Here's the thing about motors. Motors consume a lot of current. In our previous example, the LED only wanted about 20 milliamps max, whereas our current motor requires 200 milliamps minimum and could require as much as 3 amps to get started. So what does this mean for your design? An Arduino pin, such as the one used in our previous example of blinking an LED, can only supply 50 milliamps of current safely. The DC motor, however, requires 4 times that just to maintain motion. Occasionally, when electronics break down, you see smoke, and it's obvious that the part is damaged. But on top of that, the part is no longer capable of functioning in a way that you need to safely. If you were to try and drive a motor using one of the digital pins, you run the risk of damaging your hardware, anywhere from your motor simply not running to blowing up a pin on your Arduino or even damaging the computer you're using to program it. So what do we need to do about it? We want to be able to toggle our motor on and off, just like the LED blinked, using an Arduino. As a precursor, however, let's make sure we do not spin the little wheel on that motor. Applying power makes that wheel spin, so if you make that wheel spin, you're actually going to be generating power, like a generator. And we don't want to do that and damage your Arduino or your computer in the process. Let's get started safely assembling your motor hardware with your Arduino. Our first step is to take 5 volts and ground from the power pins on our Arduino and bring them to the breadboard power rails. Next, we want to get our DC motor, a push button, and diode from our kit, and assemble them as shown on the screen. Power should flow from the positive rail on the breadboard to the first lead on the DC motor. Next, it should be routed through the DC motor, through a push button, and returned to ground. In parallel with the motor, we need to include a diode. It functions as a safety precaution and is sometimes referred to as a flyback diode. It's included to prevent current from flowing in the opposite direction when a push button is suddenly released. So take a minute to build this circuit on your own breadboard. Let's assemble all the components we need to build our push button controlled DC motor circuit. Starting with our push button, next we need to get our diode, and make sure to double check that the component you've grabbed is indeed a diode. They resemble resistors that we've used previously. Finally, the DC motor. Using these components, along with our breadboard and some jumper wires, let's put our circuit together. Let's start by placing our diode. Take the leads and securely place them into separate rows on the breadboard. Next, place the motor leads such that they're parallel with the diode. Our positive lead should go to the cathode of the diode, and our negative lead of the motor should go to the anode of the diode. Double check that the leads of the motor and diode are connected in parallel, and let's place the push button. It really only fits one direction on the breadboard, so make sure it straddles the center trough. The push button should be wired in series with the diode and motor. Using this green wire, I connect the nodes at 16 to the nodes at 11. This makes the push button in series with both the diode and the motor. Our final task is to place power and ground lines on our circuit. The push button needs to be grounded, and the DC motor should be powered. Both of these jumpers are connected to the power rail on the breadboard, as opposed to going directly to the Arduino. This is to help better organize the circuit. Bringing our Arduino back, we can use jumpers to connect the power rail of the breadboard to the power headers on our Arduino. We plug in 5 volts to the positive power line on the breadboard, and we use a black wire to ground the entire circuit. Double checking that our connections are indeed correct. You really don't want to mess up power and ground. We can now plug our Arduino in and be able to test without the need of any code whatsoever whether or not we hooked up our motor correctly. By pressing our push button, we should be able to apply power to the DC motor and see it spin. If your motor spins, great job! If not, double check that your circuit is indeed assembled correctly and that your Arduino turns on and try it again. This concludes the first video of our self-paced Arduino motion workshop. Join us in the next video to learn how to use a switch that the Arduino can control.